The dualX is comprised of basically 4 sections. You have trialing, implant delivery, lockout screw delivery, and graft delivery. We're going to go through each section individually. The dualX system has some accessory instruments available as well, namely the T-handle, the slap hammer or back slap, the thread clearing tool, and the cage guide. If your surgeon finds it necessary to use the T-handle, I warn you to use it very cautiously. The X handle has so much power and is very efficient at delivering power that we really only need to use a couple of fingers on the T-handle. I don't want it being used with too much muscle like this. Just use it with 3 or 4 fingers like this. The first step of the dualX procedure is trialing. After the disc prep portion is complete, the trials come into play. The trials are calibrated to each given implant height, meaning this one says 8 to 10 on the paddle. That means that it mimics a 8 to 10 implant collapsed 8 millimeters high going in and then rotates to 10 millimeters high once in the disc space. That would correspond to the 8 to 10 implant. This one would be for 9 to 12. We want to make sure that we not only trial midline, but we also trial laterally as well. And that just makes sure that we have enough space for such a large implant. The paddle length is 28 millimeters. The implant length anterior to posterior is 25. If we can get the paddle within the disc space, that assures us that we will have space for the implant to reside in the disc space as well. The leverage bar can be used for a snug fit and makes the trial more of a T-handle. And I have the surgeon turn clockwise 90 degrees and then counterclockwise, just due to the rounded edges of each trial. The way the implant works is that we cannot stop at any given point. We have to get to the terminal height of any given implant. So if an implant says 8 to 10, I need to know that I have 10 millimeters of height. The drawbar will draw the nose back, and these sleds will slide up and down these ramps and then eventually fall into these little recesses or detents. That will provide passive lock in order to get a lockout screw across for the permanent lock. So we have to get to that height. The dualX implant delivery section of instruments is as follows. First of all, you will receive either sterile implants or a caddy with non-sterile implants that needs to get processed through SPD. The sterile implants have 2 generations actually. If you see a number 2 on it, it has the 2nd generation lockout screw in it. If you see the no number 2 on the box, please use the lockout screws from the caddy in the tray. That's all of them are generation 2 screws in the caddy. You have the dualX handle, the outer tube, the inner tube, the drawbar, the counter torque, and the cage guide. The inner tube gets put into the outer tube and mounted onto the X handle with a click. When it's time for the counter torque goes over the thumb wheel. And the cage guide can be used in multi-directions, either handle medially or handle laterally, depending on if they're using it to protect the dura or the nerve root. The lockout screw delivery instruments are as follows. In the tray, you will see a generation 1 screwdriver and retainer shaft. The inside screwdriver gets screwed into the outer shaft and can be used with the Gen 1 screws. However, we strongly encourage you to use the Gen 2 screws when possible. The Gen 1 screwdriver can only be loaded onto the black torque limiting handle, cannot be used on the fixed handle. Then you have the Gen 2 screwdriver, the torque limiting screwdriver handle, the fixed screwdriver handle, the path clearing tool, and the caddy with the non-sterile Gen 2 screws that comes in the tray. The Gen 2 screwdriver loads into the torque limiting handle with an AO connection. The flat portion of the screwdriver does not go all the way into the handle, but as long as it doesn't come out, it's loaded properly. It can also be loaded into the fixed handle as well, but use the torque limiting handle primarily. The Generation 2 screw is loaded onto the screwdriver with a slight click. The final section of the dualX procedure is delivering graft into the implant. Graft delivery instruments are as follows: the funnel, the nozzle tip, the inner tube, and then the bone tamp. The nozzle tip gets threaded onto the inner tube, and make sure it's very tight. For graft loading, about 5 cc's of some kind of putty or flowable graft can be loaded into each tube. The funnel is put onto the hex portion of the tube, but make sure to inform the scrub tech that it goes on loose and it comes off very easily. Make sure you tell the scrub tech to push down the graft into the funnel as far down into the tube as possible, and then use the bone tamp in order to load the bone graft all the way down to the nozzle tip. Setting the X handle to the starting position goes as follows. The Acme bolt has a ring that is lined up with the laser mark on the handle. That's your starting position and is held in place with the pin. If for some reason the pin has been removed by SPD, for example, or you're setting up for a second level after a first level dualX, do this. Turn the handle counterclockwise until it stops, and then 3 half turns clockwise. That will put you in a position where the ring is now lined up with the laser mark and you're ready to load the implant again. Once you've determined the height requirements of the implant, you go ahead and select it. When it's sterile, it comes in a package like this, a pouch. I want you to have the scrub tech fold back the blue pouch and expose the tail of the implant. Loading it is pretty straightforward. Put this up against your belly. You load the implant where there's no space between the implant and the outer tube, and you tighten this gray thumb wheel until it's finger tight. And then you can take the sheath off or leave it on, doesn't matter, but for demo purposes, I'm going to take it off. I'm going to have you turn the implant upside down. Don't rest it on anything because that will expand the implant. We don't want to do that. As many of you know, Amplify has been sending out a hybrid of sterile and non-sterile implants. If you are in receipt of a caddy like this, full of implants, it needs to get processed through SPD in order to prepare for the case. Determine what size the implant is by looking down at the nose of the implant. It'll be written on there, and that way you can load it straight from the caddy when you've determined the size. After the implant is loaded onto the handle and tube assembly, take it out of the caddy and just let it hang. Take the drawbar and just let it drop into the back of the handle. The drawbar assembly requires 2 steps. The first step is just using gravity. Turn the drawbar until it's tight. The second step, plunge down on the drawbar and turn while plunging until it's tight. It is critical to load the drawbar in those 2 distinct steps. Do not just plunge the drawbar and screw it down. This will lead to an improper loading of the implant. You'll notice that the implant is slightly splayed. Look through the graft window to ensure that there's no visible threads of the drawbar seen through the implant. Secondarily, look at the distal tip and make sure that the drawbar is threaded all the way to the nose. Then pull the pin and turn the handle counterclockwise. As you can see, that collapses the implant down to appropriate starting position in order to hand the implant to the surgeon for implantation. Now that you're ready to hand the inserter handle with a loaded implant to the surgeon, I want you to notice a couple of things. The end plates of the implant, the orientation is that of the thumb wheel. So the thumb wheel shows where the end plates are. Once you put the counter torque over the thumb wheel, then the handle of the counter torque will be in line with the disc space. This portion of the handle is designed to control rotation of the implant. This portion of the handle is designed to control expansion of the implant. The cage guide can be used in two orientations. The handle laterally to be used as a nerve root retractor, or the handle medially to be used to protect the dura, and then the cage is inserted down the slot. Be sure to insert the full 25 millimeters of beveled tip into the disc space when inserting the cage guide. And then make sure to remove the cage guide as the implant goes in to make sure that the cage guide doesn't get stuck. I want you to pay close attention to this area of the drawbar. It has laser marks on it and text that says collapsed. Once I start turning the expansion portion of the handle, you'll notice that I'm going to get from collapsed to laterally expanded. And you'll notice that in the disc space then, the implant went from 12 millimeters wide to 21 millimeters wide. Also, the drawbar drew the nose back and retracted it. So we will need to mallet anteriorly to get to our anterior position. The laterally expanded portion should be done under AP fluoro vision. Once the lateral expansion has been done, go back to lateral fluoro and make sure that you are anterior enough with the implant before you start going up in height. It's the same procedure. You just keep turning the handle clockwise until vertically expanded is seen. And I want you to go beyond vertical. I want you to go to where there's a little bit of silver below that black vertical line. And it takes a little bit of pressure to do so. If for some reason they're having trouble doing that, this is where I would have you use the T-handle, but very, very controlled. Otherwise, it's too powerful. So I want you to see a little bit of silver down below that vertical black line on the drawbar. That way you ensure that the implant is fully expanded. Now you have an expanded implant inside the disc space, still attached to the handle assembly. The first step is to take the drawbar, which is the knurled handle most proximal, and turn it counterclockwise. It will turn and pop, and then it'll stall. To relieve the pressure, take the handle and turn it back a half a turn. That's all you need to do. And then go back to the drawbar and remove it. There are two silver tabs down below the counter torque which get pressed and the handle assembly is removed. Now you have the tube assembly still attached to the implant. Now we place the lockout screw. There are two lockout screws, a generation 1 and a generation 2. If you see a number 2 sticker on the sterile box, generation 2 screw is included. Also, the caddy in the tray is loaded with generation 2 screws. If you don't see a 2 sticker on there, generation 1 screw is loaded. It's not ideal, but it'll still work. The screwdriver is a 2-piece screwdriver, so it's still included in the tray. The inner screwdriver goes to the outer sheath, retaining sheath, and is screwed in place. Only the black handle can deploy a generation 1 screw. Preferably, you'll have a generation 2 screwdriver, which has 2 little prongs at the distal tip. The generation 2 screw is loaded with just a snap and an AO connection on the black handle. The black handle is a torque limiting handle. If necessary, there is a blue handle, which is a fixed handle, to overcome any possible cross-threading. not used very often. So placing the lockout screw is very straightforward. The first thing I recommend is taking the path clearing tool, and this is just a centering operator, which finds the path to the nose of the implant to be collinear. We put it down the tube and insert it to where that laser mark seats at the shoulder. If for some reason it doesn't seat at the shoulder, that means that the implant perhaps is somewhat torqued on a retractor or a tube, and we need to find a place where that tube is collinear and that laser mark seats. Once that seats, hold that orientation. Have the surgeon not move orientation of that tube. That will allow the screw to track straight forward. And we'll see that that laser mark does the same thing along down the path of the screw, and then that will torque in place. The screwdriver comes straight out, and now you have an expanded implant with a lockout screw still attached to the tube. For those who have been around dualX for some time, you'll know that we've had several different methods of bone grafting. Pre-packing the disc space is acceptable if it's limited. We don't want to crowd that disc space up too much, as this implant is going to double in width. So limit pre-pack. As far as post-packing is concerned, there's a couple of different ways. The first way is to deliver bone graft prior to delivering the lockout screw. And the method for that is a couple of different ways. The first way is to keep the tube assembly attached to the implant, put the funnel on the inner tube, and put bone graft and deploy it while this tube is still attached to the implant. This becomes quite tedious and time-consuming. The other way to go about doing that is to have a tube full of bone graft loaded on the back table, and then we'll do a swap technique. And it goes as follows. So we have the tube assembly attached to the implant. Remove that inner tube, but maintain the orientation and stay docked with the outer tube. We'll replace the inner tube with one filled with bone graft. As long as I stay docked, the inner tube should still be able to be engaged, and then we'll take the bone tamp and fill with bone graft. That's called the swap technique. The important part here is to stay docked with the outer tube. Now that you have bone graft in the implant, we need to create a path through that. The path clearing tool does a very good job of clearing a path to the nose of the implant as long as you go down to the laser mark. The next step is to clear the threads with the thread clearing tool. We want to make sure that we engage clockwise down to the most distal line. The other lines are for our lateral procedure. If you get resistance here, turn through it as you are actually clearing debris, bone graft debris, from the threads, and then remove it counterclockwise before deploying the screw. The other method of bone grafting is to do so after the screw is delivered. So we would remove the handle from the tube assembly. We would take the path clearing tool and just make sure that our tube assembly is collinear with the implant and the threads of the nose. If not, the laser mark will stop short of the shoulder. Toggle the tube assembly until you're collinear. You can also check a lateral fluoro to make sure that a tube assembly is collinear. And then maintain this orientation once that laser mark seats into the shoulder. Maintain the orientation with the tube. Come straight out with the path clearing tool and go straight in with the screw. Go down to that same line and the screwdriver will torque out. come straight out with the screwdriver handle and use the funnel as a wrench to remove the tube assembly. Turn counterclockwise on the inner tube. Both tubes will come off. There are some extra inner tubes in the set and nozzle tips that come with that thread right on. Each tube will accept about 5 cc's of graft. In this case, mostly DBM putty is used. I don't want anything used that has cancellous bone chips in it or is fibrous, because we have a small aperture of the nozzle that needs to have the bone graft flow. The funnel fits onto the tube for loading, but it's loose. Remind the scrub tech that that doesn't fix on there. And the blue is the bone graft tamp. So you load the tube with 5 cc's of bone graft. After the implant is in place, the nozzle fits right into a recess above or below the screw. The nozzle doesn't fix to the implant, it just sits. So it'll fit into this area above the screw and below the screw. And then the blue long handle is the ramrod for that. Once the laser mark is reached, you know you've bottomed out as much bone graft as is going to come out. Again, 5 cc's per level is usually what we see. Thank you for watching the dualX training video. Please let us know if you have any questions. Call us here at Amplify Surgical or email us at info@amplifysurgical.com.